Our next unit begins our extensive study of triangles. The next couple of units will cover triangles in depth. We're going to focus on congruent triangles in this unit. And a lot of times this is the unit where students that have been struggling with proof, it all starts to come together. You'll start to see kind of develop meaning to why we had to do all those preliminary proofs and learn all that preliminary stuff about parallel lines or all those, the operations postulates and all of that, because there is always an end game in congruent triangles proof. We're trying to prove two triangles congruent, or we need to prove triangles congruent in order to get somewhere else. So a lot of you who have been struggling should see things kind of come together a little bit better in this unit. So this video is just intended to be an introduction to different types of triangles, and there's going to be a lot of information here. Most of what you see in this video are things that you should already know or are pretty logical. So let's first talk about different types of triangles. We can classify triangles in two different ways. We can classify them by angle measures, or we can classify them by side lengths. By angle measures, we have four different types. We have an acute triangle, which has 3 acute angles. There are no specific measures to those 3 acute angles. We have an equiangular triangle in which all three angles are congruent, and they all happen to be acute as well. We have a right triangle that has 1 right angle, and we have an obtuse triangle that has 1 obtuse angle. And by side length, you're probably more familiar with these. We have an equilateral triangle that has 3 congruent sides. We have the isosceles triangle that has at least 2 congruent sides. Notice the at least, okay? Because an equilateral triangle also has at least 2 congruent sides, right? It has 3, which is at least 2. So an equilateral triangle is always an isosceles triangle. However, an isosceles is not always equilateral. Okay, think about that for a second. And then finally, we have a scalene triangle, which has no congruent sides. So let's look at a quick example involving classifying triangles. Okay, let's take an example. Classify each triangle by angle measures and by side lengths. Well, we have 3 triangles here. We have triangle MNQ. We have triangle NQP. And we have triangle MNP. Okay, so MNQ is right here. We can see all 3 sides are 6, so that makes it equilateral. But if it's equilateral and all 3 sides are the same, then all 3 angles must also be the same. So this is also equiangular. Okay, NQP is right here. We see 3 side lengths here. We see 6, we see 3.2, and we see 8.1. That's 3 different side lengths, making NQP scalene. And then we see some angle measures here. We have 120 degrees, we have 40 degrees, we have 20 degrees. Now remember, if a triangle has even only 1 obtuse angle, that makes it an obtuse triangle. So the 1 obtuse angle of 120 degrees is making this whole triangle obtuse. And then we have MNP, which is the big triangle here. Okay. All right, so let's see. We have a side length of 6. We have a side length of 6 plus 3.2, which is 9.2. We have a side length of 8.1. Okay, so that makes that triangle also scalene because there's 3 different side lengths. Okay, but what about the angle measures? I'm going to erase some of this so that we can see a little better what's going on. Okay, so for angle measures, we have angle P is 40 degrees. We know from our equiangular designation that angle M over here is 60 degrees.
And this is 60 degrees, but plus the 20 makes this entire angle 80 degrees, right? So we have a 60-degree angle, we have an 80-degree angle, we have a 40-degree angle. All of those are acute angles. So this scalene triangle is also acute.
Let's look a little bit more deeply at the isosceles triangle. An isosceles triangle, as we mentioned, has at least two congruent sides, as you see marked here. The congruent sides are called the legs of the isosceles triangle. And then we have some special names for the angles in the isosceles triangle as well. So the vertex angle is formed by the legs. You'll see that in this case, in this example, the vertex angle is angle 3. The side opposite the vertex angle is called the base. And the base angles are the two angles that have the base as a side. So in this case, the base angles are angles 1 and 2. The isosceles triangle has two theorems associated with it, and they really just come right from the definition of an isosceles triangle. So if two sides of a triangle are congruent, then the angles opposite the sides are congruent. So essentially, if a triangle is isosceles, then its base angles are congruent. And then the converse says something similar. If we have two angles of a triangle that are congruent, then the sides opposite them are also congruent.
Okay, here's an example, an application of the isosceles triangle theorem. Find the perimeter of the triangle. Okay, well, we know that we have two congruent sides here, right? These sides are both congruent. So we can set those sides equal to each other to find out what x is. Right, we solve, we get x is equal to 9. But the question asks for perimeter. So if x equals 9, then this base of the isosceles triangle is 23. And we have the legs of the triangle being 29, both of them 29. Okay, so the perimeter is 29 plus 29 plus 23. Okay, and that's 58 plus 23, which is going to give us 81 units, whatever the units are. Okay, another application of an isosceles triangle. We have the vertex angle of an isosceles triangle that measures A plus 15 degrees. So let's draw this. Right? Here's the vertex angle, right? If we assume those two guys are congruent, the vertex angle is A plus 15. One of the base angles is 7A, but that must mean the other base angle is also 7A because the base angles are congruent. So find A in each angle measure. Okay? Well, we're going to use the triangle sum theorem here as well, because we know that 7A plus 7A plus A plus 15 is 180. So that's 15A plus 15 equals 180. So 15A equals 165, which means A equals 11. Okay, so each angle measure, we have two angles that measure 77 degrees. And then that vertex angle is 11 plus 15, or 26 degrees.
Okay, we also have a few theorems about equilateral and equiangular triangles. These are actually technically called corollaries, which are just theorems that follow right from another theorem. So we might be using another theorem in the proof of these corollaries. So if a triangle is equilateral, then it's equiangular. And likewise, if a triangle is equiangular, then it's equilateral. Again, these are very logical. So every triangle that's equilateral is equiangular, and vice versa. So if you're given that the sides are all congruent, you may assume or conclude that the angles are congruent. If you're given the angles are congruent, you may conclude the sides are. All right, we have the triangle sum theorem, which again, it's one we've kind of used, we've played around with here in class. We just haven't formally stated it, that the sum of the angle measures of a triangle is 180 degrees. And here you see the proof, you see it in flowchart form. And notice it uses an auxiliary line, which we used when we looked at crook problems. Okay, so we could draw a line through that vertex B of that triangle. And that line is going to help us prove that the sum of the measures of the triangle is 180 degrees. You can see by alternate interior angles, 1 and 4 are congruent. And by the same logic, 3 and 5 are congruent, which makes us conclude that the measures of 1 and 4 are equal, as well as the measures of angles 3 and 5. Okay, and along that auxiliary line, we can say that the measures of angle 4, 2, and 5, when we add them, they're 180 degrees because they are a straight angle. And then we could just substitute 1 for 4 and 3 for 5, and we get the conclusion that angles 1, 2, and 3 add up to 180 degrees. So that's just a proof of the triangle sum theorem and why it works. Okay, a couple of corollaries that come from the triangle sum theorem is that the acute angles of a right triangle are complementary. If we think about that for a second, right? If all of the angles of a triangle add up to 180, and in a right triangle, one of those angles is 90 degrees, then the other two angles must add to 90, which means they're complementary. And likewise, the measure of each angle of an equiangular triangle must be 60 degrees, because again, if all three of them add to 180, we know that they're all equal, or they're all congruent. They must all measure 60 degrees in an equiangular triangle. So those come directly from the triangle sum theorem. The exterior angle theorem says that the measure of an exterior angle of a triangle is equal to the sum of the measures of its remote interior angles. Okay, so that's a lot of vocabulary all in this one theorem. Let's just talk about what we're referring to here. So we have a triangle down here. The interior of the triangle are all the points inside. The exterior are all outside. Okay, so in this case, angle 3 is an interior angle, and angle 4 is an exterior angle. But angles 1 and 2 are what we call the remote interior angles of angle 4. Okay, so they're the interior angles that are far away. They're remote from angle 4. Okay, angle 3 is adjacent to it. Angles 1 and 2 are remote. So again, think about this for a second. Does it make sense to you that angle 4, that exterior angle of the triangle, is equal to the sum of the measures of angles 1 and 2? So we can just do a verbal proof of this, right? Think about this. Angles 3 and 4 will add to be 180 degrees. And we know that angle 1, 2, and 3 will also add to be 180 degrees. So we can do a substitution. We could substitute the sum of 1 and 2 for 4. And we can indeed see that 1 and 2 together are equal to the measure of angle 4. Let's take an example of the exterior angle theorem.
The exterior angle is equal to the sum of the remote interior angles. Okay, so in this case, right, angle BCD is the exterior angle, and angles A and B are the remote interior angles. Okay, so we could set up the equation 5x minus 60 equals 2x plus 3 plus 15, right? Because the sum of the remote interior angles is equal to the measure of the exterior angle. Okay, and solving, we get 3x equals 78. So x equals 26. Right, it says use the exterior angle theorem to find the measure of angle BCD. Okay, well that's this angle right here. So if we substitute 26 into that angle, 5 times 26 minus 60. 5 times 26 is 130 minus 60 equals 70 degrees.
And then we have the third angles theorem, which again, it's a theorem we've kind of already used. We just haven't formalized it yet. If two angles of one triangle are congruent to two angles of another triangle, then the third pair of angles must be congruent. So again, if they all add to 180, and we know that two pairs of their angles are congruent, then that third one has to be congruent as well. Again, this is just a pretty logical theorem.
Finally, we have an example that uses the third angle theorem. Okay, remember that the third angle theorem says that if we have two pairs of congruent angles across two triangles, then the third angle must be congruent, right? And here we see that we have angle O and angle R are congruent as marked, and angle M and angle Q are also congruent. So that means that angle N must be congruent to angle P. Right, so we could set them equal to each other. X squared plus 50 equals 3x squared. And then we could solve. 50 equals 2x squared, which means x squared is 25. So x is either plus or minus 5. Right? And in this case, it doesn't make a difference whether it's plus or minus 5 because we're going to be squaring it in both situations, which will kind of negate that negative sign. Right? So if we substitute it in to find the measure of angle N and P, we see 5 squared is 25 times 3 is 75 degrees, and we could just double check if we substitute it in for angle P. 5 squared is 25 plus 50 is also 75.
See you in class tomorrow.